Okay, we're going to look at 2021 paper 1 question 3. Part A of this question was a bit strange and there's a load of different ways of doing it, so if you've done it a different way to the way I'm about to do it, then that's fine. However, I think that this method is probably the most simple way of doing it. First of all, we're given a cuboid. We're just a rectangular block and the dimensions are x, y and z. And we're asked to work out the volume of the cuboid. Well, to get the volume of a cuboid or a three-dimensional shape, in this case it's just x times y times z. However, we haven't been given x, y or z. We've been given the area of each of the faces. The first face is this dimension is x, this dimension is clearly z. If I wanted to get the area of this one here, it would simply be x multiplied by z. So based on that, I can tell that x multiplied by z must be equal to 2 root 2. Then if I wanted the large face to the side, it's clearly y multiplied by z. So I can deduce that y multiplied by z must be 8 root 6. The third face along the top is x times y, so I can clearly see that x, y is equal to 4 root 3. So that's the information that we have. We need to work out the volume, we need to work out what x multiplied by y multiplied by z is. And we don't have any of them individually, but we have xz, yz and xy. So in an exam, you just kind of have to use trial and error and play around with the numbers a little bit and see if anything will happen for you. What I noticed when I started looking at this was that 8 root 6 divided by 2 root 2 is 4 root 3. So what I decided to do here was I decided to take yz and xz. What I'm going to do is divide yz by xz. The reason I chose to do that is because just using my calculator, I figured out that 8 root 6 divided by 2 root 2 will give me this. So I wasn't really sure why that was relevant, but hopefully we'll be able to do something with it now. So yz is equal to 8 root 6 and xz is equal to 2 root 2. Now what you should notice here is on the left hand side the z's will simply cancel and I'm left with y divided by x. And on the right hand side I've got 8 root 6 divided by 2 root 2 and 8 root 6 divided by 2 root 2 is in fact 4 root 3 if you just plug it into your calculator. But now I noticed that 4 root 3 is the other value. 4 root 3 is actually x times y. So on the right hand side now I can sub in, instead of 4 root 3 I can put in x times y. So now what you should notice is that y over x equals x times y. So I've simplified it down a little bit. Rather than having an equation in 3 variables, I have an equation in 2 variables. Let's just imagine what would happen here if I decided to get rid of my fraction. If I want to get rid of my fraction, I'm going to multiply both sides by x. If I multiply the left hand side by x, I'll simply get y. If I multiply the right hand side by x, I'll get x squared times y. Now I noticed, right, well how could y be equal to x squared times y? So I decided, right, it's the x squared that I'm going to focus on. There's a y on both sides. So I'm going to divide both sides by y. If I divide y by itself, I get 1. And if I divide the right hand side by y, the y is simply gone. And now I'm happy out. I have one equation and one unknown. So I can actually say that this means that x must be equal to 1. If x squared is equal to 1, I get the square root of both sides. And I've actually worked out a value for x. Now the way that I did it there, yz over xz, you'll also end up with basically the same thing if you take yz over xy. You end up kind of with the same conclusion that x is equal to 1. If x is equal to 1, then this question all of a sudden is really easy. Originally I said the volume is x by y by z. And I can now say that, right, well x is simply 1, y times z, I have it from the question, y times z is simply 8 root 6. So the volume is just 1 by 8 root 6. This is my x, this is my yz. And that's my answer. So 1 times 8 root 6, obviously if you multiply by 1 then it just stays the same. So my final answer is 8 root 6 centimeters to be cubed. In question 3 part B, the first part, part I, is very straightforward. We're simply given a quadratic and we're asked to find the 2 roots. All we need to do there is factorize and solve our quadratic. So the factors of our quadratic are 3x minus 7 times x plus 5. When we solve it, you get x equals 7 over 3 or x equals minus 5. Now we're going to use those answers to figure out part II. Now in B part II, we're asked to solve the following equation. It says hence or otherwise solve this equation. This is very similar to the types of questions we did in indices and logs 6 and 7. This is a quadratic equation where we're going to use substitution. The first thing I decided to do was to move everything to the left hand side. Now, you should recognize already that this is quite similar to the quadratic we had in B part I. In the quadratic in B part I, we had 3x squared plus 8x minus 35. So let's just discuss how we could convert what we have here into exactly the same as what we had in the previous question. What we could do is decide to use substitution in order to get rid of the unknown in the powers. I'm going to sub in x instead of 3 to the power of m. If I do that, then the second term would simply become plus 8x, and the third term will obviously stay as minus 35. The first term is the only one that might cause bother. The first term, I have 3 to the power of 2m plus 1. And I could split that up and write it as 3 to the power of 1m plus 1m plus 1. Now, if you go to page 21 on your maths tables, the first rule on the top left-hand corner, it's a rule of powers. And it tells me that a to the power of p plus q is the same as a to the power of p multiplied by a to the power of q. Based on that, I can rewrite 3 to the power of m plus 1 as 3 to the power of m times 3 to the power of m times 3 to the power of 1. But I decided that everywhere there's a 3 to the power of m, I'm going to sub in an x. So that means that this will become x times 3. So I started off with quite a complicated looking expression, but I'm just ending up with 3 times x, or in other words, 3x squared. Now, this looks identical to what I had in B part I. I know that if I solve this quadratic, my two answers are x is equal to 7 over 3 and x is equal to minus 5. But obviously, I made up x halfway through this part of the question. There's no x in the original question. So now I need to go back and figure out what x actually represents. Everywhere there was a 3 to the power of m, I subbed in an x. So I need to go back and substitute back in the 3 to the power of m. If x equals 7 over 3, that means that 3 to the power of m must be equal to 7 over 3. If x is equal to minus 5, that means that 3 to the power of m must be equal to minus 5. At this point, you should recognize that the question asks to give your answer. It doesn't ask to give your answers. So there's not two answers. We have to eliminate one of these. It's impossible for 3 to the power of m to give me something negative. If this was 3 to the power of minus a million, it's just a really, really small positive number. But I'll never have 3 to the power of m giving me something negative. So this doesn't make sense. And I'm going to simply get one answer from 3 to the power of m equals 7 over 3. Okay, so now we have 3 to the power of m equals 7 over 3. Now the unknown is in the power. And usually, and in all the videos we do in indices and logs, when we're introducing logs, we introduce the natural log. However, there's good reason not to introduce the natural log here. You should recognize we've been told a format to leave our answer. And in our answer, we have to have a log to the base 3. So we don't want to introduce the natural log this time. What we're going to do, because the unknown is in the power, we have to introduce logs. Because there's a log to the base 3 in the answer, we're going to introduce a log to the base 3. It's really easy to do so. You literally just stick in log to the base 3 on the left hand side and log to the base 3 on the right hand side. Now, make sure you've got page 21 in your maths tables open. The third rule in the middle column tells me if I've log of something to a power, I can just bring the power in front. And that's the whole point of introducing logs here, is that we can eliminate the unknown in the power. No more power, so we're definitely happy with that. The second rule tells me that if I've log of 7 over 3, I can rewrite that. It's log 7 to the base 3 minus the log of 3 to the base 3. So it's the numerator minus the denominator basically. And now you should remember that if you've logged 3 to the base 3, if you have the same number here and here, it simply has a value of 1. So the left hand side is just m times 1, or in other words just m. Log 7 to the base 3, well that looks very similar to the format I want my answer in, so I'm not going to plug that into my calculator. Log 3 to the base 3, that's simply 1. So that's my final answer. M is equal to log 7 to the base 3 minus 1.